What's up, everybody? Welcome to chemistry class with Miguel. Today, we'll talk about chemical quantities. The mole. The mole is a fundamental unit in chemistry. Similar to a dozen, just as a dozen means 12, a mole represents 6.022 times 10 to the 23rd particles, atoms, or molecules. This number is known as Avogadro's number. No, not avocado or abogado. Avogadro's number. Mass. Mass in chemistry refers to the amount of matter in a substance. It is usually measured in grams. Each element has a specific atomic mass found on the periodic table, representing the mass of one mole of its atoms. Atoms. They are the basic units of matter and the defining structure of elements. They consist of a nucleus that's made out of protons and neutrons, with electrons orbiting around. In a mole of any element, there are 6.022 times 10 to the 23rd. Remember this number. It's very important. Remember it's Avogadro's number. Now, let's learn how to calculate molar mass. Molar mass is the mass in grams of one molecule of a substance. For reference, we'll use water, H2O. We have to split the compound, which is H and O. H has an atomic number of 1, and oxygen an atomic number of 16. Hydrogen, as his atomic number is 1, it's 1 gram per mole. But we have to multiply times 2 because we have H2. Oxygen's atomic number is 16. That's why we have 16 grams per mole. We have to add both grams per moles, which leaves us with 18 grams per mole. That's water's molar mass. Now let's calculate how many grams are in 6 moles of potassium hydroxide. Grams equals moles times molar mass. So first, we need to have the molar masses of each of these 3 elements. Potassium has an atomic number of 39.098. We have to multiply that by 1 because we only have 1 of potassium. Then, oxygen has an atomic number of 15.99. We have to also multiply that by 1. Hydrogen has an atomic number of 1.0078. We also have to multiply that by 1. If we add all of the grams per moles, that leaves us with 56.1048 grams per mole. Then we need to multiply that by the number of grams in 6 moles. So, moles times molar mass, 6 times 56.1048 leaves us with 336.628 grams. But how do we know how many atoms are in 5 moles of water? Atoms equals moles times Avogadro's number. In this case, it will be, since we want to know how many atoms are in 5 moles, it will be 5 times Avogadro's number, which is equal to 3.011 times 10 to the 24th. But what if you get asked how many atoms are in 50 grams of water? Well, atoms equals mass divided by molar mass times Avogadro's number. As we know, the molar mass of water is 18 grams per mole. So now we only need to divide 50 grams by 18 grams times Avogadro's number, which is 1.67 times 10 to the 24th. Which means that in 50 grams of water, there's 1.67 times 10 to the 24th atoms. Here are some key things to remember. Avogadro's number is 6.022 times 10 to the 23rd. Molar mass is the mass in grams of 1 mole or molecule. Grams equals moles times molar mass. Atoms equals moles times Avogadro's number, or mass divided by molar mass times Avogadro's number. Now, I'm going to show you some examples of how to apply these formulas to achieve the results that we get asked. I appreciate your attention, and I hope this was very useful for you to understand chemical quantities. Thank you.